Okay, so our new unit is going to be over probability. So, for example, when tossing a coin, there are two possible outcomes. There's heads and there's tails. Suppose you're looking for heads. So you're playing a game with somebody, you guys flip a coin, you call heads, so that's what you're hoping happens. That's what you're hoping it lands on. If the coin lands on heads, this would be a favorable outcome. So the chance that some event will happen, in this case getting heads, is called probability. So like we say the word probably a lot during the day, and it's kind of what that means. Like there's a chance, it's not 100%, but there's a chance that it could happen. You can use a ratio to determine probability. The probability of an event is a number from 0 to 1, including 0 and 1. So the closer a probability is to 1, the more likely it is to happen. So think about it as like a percentage from 0 to 100. 0% being impossible to occur, equally likely to occur, like a 50% chance, or certain to occur, 100% chance. So example 1, there are 4 equally likely outcomes on the spinner. Determine the probability of spinning green or blue. So first we have to figure out how many different options we have. So how many total outcomes do we have possible? That would be 4. We've got red, blue, yellow, and green. So the total would be 4, and in this case, the number of favorable outcomes, that's what you want to happen. So the question is the probability, that's what that P stands for, it just means probability of a green or a blue. So look at your spinner, how many green and how many blue do we have? We have 1 of each. So we add those together, so that gives us 2. So 2 out of 4, and we can reduce that down to 1 over 2. If we write that as a decimal, 0.5 or 50%. There's a 50% chance you'll get a green or a blue on this spinner. So complementary events are 2 events in which either one or the other must happen, but both cannot happen at the same time. The sum of the probabilities of complementary events is 1. So think about it as complementary events, total is 1 or 100. So if there's a percentage that something will happen, there's got to be a percentage that something will not happen. So example 2, there's a 25% chance that Sam will win a prize. What is the probability that Sam will not win a prize? So they work it out as the probability of a win plus the probability of a non-win equals to 1, or 100%. So they turn their percentages into a decimal, so 25% they write as 0.25 plus we don't know equals 1. And then they subtract, they solve like they would a regular equation, and they end up with 0.75. You can also think of this as percentages like I wrote up here. So if there's 100% chance, and we take away the 25% chance that she's going to win, we're left with 75%. Okay, or 0.75 or 3/4. 3 different ways that we need to look at this. So another complementary event, there's a 90% chance that it will rain. What is the probability that it will not rain? So same thing. Out of 100% chance, or just 1, we can take that 90 away and we're left with 10%. So there's a 10% chance it will not rain, or 0.1. Next part, 1 pen is chosen without looking from a bag that has 3 blue pens, 6 red, and 3 green. So determine the probability of each event. Express each answer as a fraction, a decimal, and a percent. Okay, so first thing you want to do is you want to see how many total pens we have. So I've got 3 pens plus 6 pens plus 3. That gives us 12. So basically, your denominator for each of these probabilities is going to be 12, because that's how many total you have. So out of 12, how many pens were green? 3. So 3/12, and I can reduce that down to be 1/4. So that's 1/4, that's in fraction form. If I want this in decimal form, all we have to do is divide it. So 1 divided by 4. And that'll give me 0.25. All three of these are going to be ones that you guys know. You know that a quarter is 0.25 or 25%. But just for future reference, if you end up with a fraction and you don't off the top of your head know what the percentage or the decimal version is, you can always divide it and work it out. Number 3, blue or red. So the probability that you're going to pick a blue or a red pen. So blue pen, there was 3 of them. Red pens, there was 6. So we want to add those together. Anytime they give you that word or, it's talking about combining them. So 6, 7, 8, 9 over 12. And I can reduce that down. 3 will go into both of those. So 3 will go into 9 3 times. 3 will go into 12 4 times. 3/4, again, if I didn't know off the top of my head, I can always divide to get my decimal and my percentage. So 3/4 is 0.75 or 75%. Then number 4, the probability of a non-red pen. So there's 6 red, so we don't want red. We're looking for green or blue. So that would be 6 of them. So 6 over 12. You can reduce that down to 1/2. Again, you can divide if you need to. 0.5, 50%. Okay, on the back page, a set of 30 event tickets. So 30 event tickets, that's my total number placed in a bag. There's 6 baseball, 4 hockey, 4 basketball, 2 football, 3 symphony, 2 opera, 4 ballet, and 5 theater. Holy cow. 1 ticket is selected without looking to determine the probability. So that 30, that's my total. My total number of tickets I have altogether. So number 4 says the probability of choosing a basketball ticket. So there's 4 basketball tickets. So I'm going to put 4 over 30. And I can reduce that down. 2 will go into both of those. 2 goes into 4, 2 times, 2 goes into 30, 15. And that's my final ratio. Number 5, probability of a sports event. So sports event would include baseball, hockey, basketball, and football. So all together I've got 16 sports events. So 16 over 30. That can reduce down by 2, I believe. 8 over 15. That's as low as it can go. Number 6, opera or ballet. So how many opera tickets are there? There's 2 plus how many ballet tickets are there? 4. So 6 over 30, and I can reduce that down by 6. That'll give me 1/5. Number 7, the probability of pulling a soccer ticket. Well, if we go back up and we look at this problem, I didn't see any soccer tickets. So the probability of me pulling a soccer ticket out of this whole bucket is 0. Number 8, the probability of pulling a non-symphony ticket. So there were 3 symphony tickets, so everything else added up. That should be 27. So there's 27 other tickets in there over 30. And I can reduce this down by 3. So 9/10. So what these mean basically is once you reduce it down, so 9/10. So that means if I dig in this bag of tickets 10 times in a row, 9 out of those 10 times, it's not going to be a ticket for the symphony. That's just kind of what that means. Number 9, the probability of pulling a theater ticket. So there's 5 of those, 5 theater tickets, and 30 overall tickets. So we can reduce that one down as well to 1/6. On the bottom part, the spinner shown is spun once. Determine the probability of each event. How likely is each event? So I'm going to number these off because they're kind of hard to see. 5, 6, 7, 8. So we've got a spinner 1 through 8. So the probability of an even number being pulled. So I've got 1, 2, 3. That's not an even number. 1, 2, 3, 4. So I've got 4 even numbers out of 8. So reduce that down 1/2. So there's a 50% chance that that's going to occur, that you'll land on an even number rather than an odd. Prime numbers. Okay. Prime numbers, remember, are numbers that only have 2 factors, being 1 and the number itself. And that does not include 1. After much confusion today, does not include 1. So our prime numbers on this one should be 2, 3, 5, and 7. 2, 3, 5, and 7. So 1, 2, 3, 4. So there's 4 prime numbers out of 8 numbers. Same thing. There's a 1/2, 50% chance that I'll pick a prime number. Number 12, the factors of 12, the probability of pulling a factor or landing on a factor of 12. So let's look at our wheel. The factors of 12 on here are, we've got 1, 2, 3, 4, and 6. So that's 1, 2, 3, 4, 5 numbers out of 8. And that's as low as we can make that fraction. Number 13, a composite number is basically the opposite of prime numbers. So everything on this wheel that's not a prime number, basically, except for 1. 1 is not included in that either. So we already used 2, 3, 5, and 7. So the only ones left are 4, 6, and 8. Okay, so 1, 2, 3. So 3 over 8. Those are my chances, the probability that I'll land on a composite number. Number 14, the probability of landing on a number greater than 10. Do you see any numbers greater than 10 in this wheel? No. So it's going to be 0. The probability is 0. 0% chance you're going to land on a number that's bigger than 12. And then 15, neither prime nor composite. There was only one number that did not qualify as prime or as composite, and that was the number 1. So 1 out of 8 is not prime nor composite, so 1/8.